We learned much about graphing polynomials just from the intercepts. And we saw that to complete our graph, we need to understand what happens for large values of x. So we learned how polynomials behave for large values of x algebraically. We saw that for large x, a polynomial p of x behaves like an x to the n. Or in other words, the polynomial behaves like its lead term. So to understand how polynomials behave for large values of x, we look at how the lead term, an x to the n, behaves for large values of x. We will abbreviate large values of x as x going to infinity on the right-hand side and x going to negative infinity on the left-hand side. Let's see how our polynomial behaves one side at a time, starting with the right-hand side. As x is going to infinity, x to the n will be getting really large and going off to infinity as well. Because if we take a really large number and multiply it by itself several times, it's only going to get bigger. But what about the an piece? If an is positive, then p of x, which is roughly an x to the n, will be positive as well, because an is positive and x to the n is positive. And if we multiply two positive numbers, we get a positive number. So we get that if an is positive, then for x going off to infinity, our polynomial p of x is also going off to infinity. And if an is negative, then p of x is an times x to the n again, but now we have an, which is negative, times x to the n, which is positive, which gives us a negative number. So p of x will be very large, but negative. In other words, if an is negative, then for x going off to infinity, p of x is going off to negative infinity. Now let's see what's happening on the left-hand side. This side is a bit harder, because for x going to negative infinity, x to the n could be going to positive infinity, but it could be going to negative infinity. This is because if n is even, like 2 or 4, then even if x is negative, x to the n will be positive. But if n is odd and x is negative, then x to the n, a negative multiplied by itself an odd number of times, will also be negative. So if n is even and an is positive, then an x to the n is positive as well, and our polynomial is going off to positive infinity. But if n is even and an is negative, then an x to the n is a negative times a positive, which is negative, and our polynomial is going off to negative infinity. If n is odd and an is positive, then an x to the n is a positive times a negative, which is negative. So our polynomial is going off to negative infinity again. And in our final combination, if n is odd and an is negative, then an times x to the n is a negative times a negative, which is positive. So here again, our polynomial is going off to positive infinity. Let's consolidate what we just saw. If n is even and an is positive, then on both ends of our graph, our polynomial will be going off to infinity. If n is even but an is negative, then we saw our polynomial is going off to negative infinity on both ends. And if n is odd and an positive, our polynomial is going to infinity on the right-hand side and negative infinity on the left-hand side. And finally, if n is odd and an is negative, then our polynomial is going off to negative infinity on the right-hand side, while it goes off to positive infinity on the left-hand side. It's worth pointing out here that it is easier to use this logic to figure out the end behavior for each graph than to memorize all of these scenarios.